Welcome to another laboratory session. In this experiment, you will determine the pH of solutions and explore precipitation and gas-forming reactions. In part 1 of the experiment, we will test for hydroxide and hydrogen ions. So first we're going to label 2 test tubes. We're going to label one acetic acid, and we will use the abbreviation AA. And then we will label the other sodium bicarbonate, and for that we will use the abbreviation SB. Now I'm going to pour 10 mL of tap water into each of the test tubes. So 10 mL of tap water into each of the test tubes. To use a pipette to add 10 drops of acetic acid in the test tube labeled acetic acid. Now I'm going to swirl the test tube to mix the contents. And I'm going to place a funnel on top of the test tube and use the measuring spoon to the test tube labeled sodium bicarbonate. So in the test tube labeled sodium bicarbonate, I'm going to add half a test tube of sodium bicarbonate. So I'm going to do a level half teaspoon. And I'm going to use the stirring rod to thoroughly stir the solution. Now make sure that when you're stirring with the stirring rod, do not drop the rod onto the bottom of the test tube, because you will bore a hole into the test tube. So I'm dissolving the sodium bicarbonate in a metal forceps to dip a pH paper strip into the test tube. So I'm testing the acetic acid solution by dipping a pH paper strip into the solution. So as you can see, the strip is pale orange, and this matches pH 4 on the this is about pH 4 on the key. Now I'm going to use the other pH paper strip to test the sodium bicarbonate. And sodium bicarbonate is basic. So notice we have a dark green color. Okay, so we're going to save the sodium bicarbonate solution for part 2. So I'm dissolving the sodium bicarbonate. In part 2 of this experiment, we will test for the bicarbonate ion. The presence of the bicarbonate ion is indicated by bubble formation when acid is added. Carbon dioxide gas is released. So first we're going to observe the sodium bicarbonate test tube that I'm holding, and notice that the solution is colorless. So you are to record this observation in table 3. So you should record this as your initial observations. Then we're going to use a pipette to add 5 drops of 4.5% acetic acid to this test tube. So we're adding 5 drops of 4.5 acetic acid to the test tube labeled sodium bicarbonate. So I'm adding another 5 drops of the acetic acid. Notice you have bubble formation. So notice bubbles are formed in the test tube. All right, now you're to record your observations in table 3 as the final observations. So bubble formation is seen in the test tube. 3 of this experiment, we'll be testing for the sulfate ion. Now, Epsom salt, a common item found in drugstores, contain sulfate ions. When barium chloride is added to a solution containing the sulfate ion, a white precipitate of barium sulfate is formed. Now, a precipitate is a reaction in which solid formation occurs. Now, there are a few precautions that you need to follow when handling barium chloride. First, do not breathe the vapor and avoid getting it into your eyes, on your skin, or on your clothing. So in part 3, we're going to use a metal forceps to place 5 large grains of Epsom salt into a test tube. So we're going to place 5 large grains of Epsom salt into a test tube. And then we're going to use a new pipette to measure and pour 1 ml of tap water into the test tube. So we're going to add 1 ml of tap water. One drop of acetic acid. to the test tube. I'm going to swirl and mix the solution. Then I'm going to use a new pipette to add 4 drops of a 0.1 molar barium chloride solution to the test tube. So 4 drops of 0.1 molar barium chloride to the test tube. So note now that I have a white precipitate. So here I have a white precipitate. In part 4 of this experiment, we will test for the phosphate ion. So first I'm going to use a 10 ml graduated cylinder to measure and pour approximately 1 ml of a 0.1 molar zinc acetate into a clean test tube. So I'll measure the 1 ml of zinc acetate. And now I'm going to rinse this graduated cylinder. Thoroughly. With DI water. Now I'm going to observe the solution in the test tube and record the observations in table 3 under initial observation. So as you can see, the solution is colorless. Now I'm going to use the clean, dry graduated cylinder to measure and pour 1 ml of a 0.1 sodium phosphate tribasic into the test tube and mix thoroughly with the stirring rod. So 1 ml. And I'll mix it thoroughly with the stirring rod. So I'm going to clean in the stirring rod. I'll mix it thoroughly and notice that a white precipitate is observed. Of this experiment, we will test for calcium ions. In part 5 of this experiment, we will test for calcium ions. The reaction that you will be observing is the reaction between sodium fluoride and calcium acetate. So here we're going to use the 10 ml graduated cylinder to measure and pour 10 mLs of sodium fluoride into a test tube. So we're going to measure 10 mLs of sodium fluoride into the test tube. Then I'm going to clean the test tube, and I'm going to measure a 0.3 I'm going to measure 3 mLs of a 1 molar calcium acetate solution, and I will add it to the test tube and swirl to mix the test tube, to mix the content of the test tube. Now, notice that the initial solution is colorless. So now I'm going to measure I'm going to measure 3 mLs of a 1 molar calcium acetate solution, and then I'll pour it into the test tube, and I'll swirl it to mix the content of the test tube. So 4 mLs of So I'm going to swirl the test tube to mix the content, and then I'm going to set a timer for 20 minutes and observe the reaction. So I'll set my timer now for 20 minutes, and then I will observe the reaction. In part 6 of this experiment, we will determine the identity of the unknown chemical. The unknown chemical could be a sulfate, bicarbonate, or a phosphate. The results need to match those from the previous experiment for a positive identification. So first, I'm going to use a permanent marker to label 3 test tubes. So we're going to label them B for the bicarbonate test, and S for the sulfate test, and P for the phosphate test. So all 3 test tubes have been labeled. Now I have already removed the lid and cover from the unknown solution, and I'm going to use the 10 ml graduated cylinder to measure and pour 2 mLs of the unknown solution into each test tube. So into the first test tube, I'm pouring 2 mLs of the unknown solution, and then I will do the same for all 3 test tubes. Now I'm going to perform the bicarbonate test by pipetting 5 drops of acetic acid into the test tube labeled bicarbonate ion test. So here I am going to add 5 drops of acetic acid. And as you can see, nothing happened. And I will indicate my results in table 4. Next, I'm going to perform the sulfate ion test by dropping 1 drop of acetic acid and 4 drops of barium chloride. So 1 drop of acetic acid, and then I'm going to use a new pipette to deliver 4 drops of barium chloride. So here we have the formation of a milky or white precipitate. Now I'm going to perform the phosphate ion test by pipetting 1 ml of zinc acetate into the test tube labeled phosphate ion test. So I'll be using the 10 ml measuring cylinder to deliver the 1 ml of zinc acetate. Okay, so notice the solution is colorless like it was before the test. And again, I will record the results in table 2. Now record a positive result if a reaction took place and a negative result if there was no reaction. So under the bicarbonate, you will say negative result. For the sulfate, you will say positive result. And for the bicarbonate, you will report a negative result. For the sulfate, you will report a positive result. And for the phosphate, you will report a negative result. If you have any questions about this lab, feel free to send me an email, or when you come to our class session, you can ask a question. Thank you for watching this video.